Hi guys, good morning to all of you. So let us start our session. Yes, guys, do you hear me? Hello, guys, do you hear me? Okay, yeah. Thank you for your response. So let us start our session. Yes, yesterday, just we have discussed about all the introduction. Just overview, course overview we have discussed, course contents. Okay, just we have discussed about course contents. Okay. Yeah, no problem. It's your first day, no problem. Yesterday, nothing discussed. Yes, yesterday, just only course overview discussed about myself introduction, about course view, course contents, only the topic discussed. Tomorrow, yes, sorry. Today we are starting actual topic. Okay. Yes, here I'm not expecting anything from you. No expectations. Okay, no prerequisite for this to learn Linux base. Even beginner also can understand this Linux base. I'm starting from very basics. Okay. Yes, yesterday last 10 minutes just given some introduction to that basics here. From that I'll start it here. Starting from basics. Okay. So first of all, computerware. Yes, computerware. See, computerware, there are two categories. First one, hardware. Second one, hardware and software. So what is hardware? What is software? Yes, from the beginning, I'm starting here from very basics, fundamentals. After finishing all these software fundamentals, next we'll go to Linux base. Okay, hardware. So what is hardware? Yes, hardware. Yes, these are physical components. These are physical components of a computer. These are physical components. Physical components of a computer. Just physical components of a computer, right? So these are physical components. Okay, hardware. Just these are physical components of a computer. Okay, so physical components. Yes, like keyboard, next mouse. Yes, maybe hard disk. Okay, motherboard. Okay, yes, next processor, next RAM. All these are physical components, right? These are physical components of computer. Yes, we can touch physically, right? Okay, this is hardware. Okay, so hardware, this is not our part. Yes, our part is software. So let us start with software here. Yes, our part is software. So what is software? See, in software, everything is program. Yes, here everything. Yes, everything is a program. Yes, everything is a program. Yes, in software, everything is a program. Okay. Yes, programs. Everything is a program. Yes. Simply you can say it's a collection of programs. All the programs, software, in software, everything is program. Simply we can say it's a collection of programs. Okay, software. Yes, it is a collection. It's a collection. Yes, collection of programs. It's a collection of programs. Okay, software, it's a collection of programs. Okay, programs like maybe C program, yes, maybe C++, yes, Java, yes, Python, yes, maybe Hadoop. Okay, Hadoop, maybe HTML, yes, HTML, something like this. All the programs, right? Software. In software, everything is program. It's a collection of programs like C++, Java, Python, Hadoop, HTML, something like this. So these are software, right? This is software, right? Next, in software, there are two categories. There are two categories in software. There are two categories. Two categories. There are two categories in software here. So first one, system software. First one is system software. First one is system software. Next one is application software. Next one is application software. System software, next application software. So first one system software, next application software. See, Linux comes under system software. Okay, so what is system software? Let us see about system software. So what is system software? System software, yes, this one interacts, this one, yes, interacts with the hardware components. This one interacts with the hardware components. System software interacts with hardware components, right? Okay, this one system software, this one interacts with hardware components, like, okay, right? Yes, for example here, for example, yes, here system software, this one interacting with hardware components, right? Interacts with hardware components. Example, yes, drivers, device drivers and operating systems. Device drivers and operating systems, right? Device drivers, operating systems comes under this category, right? Yes, operating systems, OS. Linux is a OS, right? Linux is a OS. Linux is OS. So our part comes under system software. Ours is system software, right? So here this is our part, system software. Linux is comes under, Linux comes under system software here. Before going to system software, let us see something about application software. Yes, we'll see something about application software. So what is application software? The application software, this is for the purpose of application development. This is for the purpose of application development, just for the purpose of application development, we can use this application, yes, development, for the purpose of application development. Okay, application software for the purpose of application development. Okay, for the purpose of application development, we can use this development, right? For the purpose of application development, yes, application, yes, apps, yes, every day we are working with different applications, right? Apps like Facebook, it's an application. Okay, Gmail, it's an application. Yes, Google, it's an application, right? Okay, next, WhatsApp, yes, WhatsApp. Okay, yes, WhatsApp, call us WhatsApp, don't say WhatsApp. WhatsApp is not correct, WhatsApp. Okay, so WhatsApp, it's an application, not app. It's an app, it's an application, WhatsApp. Okay, so WhatsApp. Next, Durga website, Durga website, Durga website, right? Yes, all the applications, right? How to develop these kinds of applications here? How to develop all the applications here? For this purpose, we need some application softwares. Depends on requirements, we can use different kind of application softwares. Okay, like Java, HTML, C++, something like this. Suppose, for example, here, yes, an application, maybe web application, something like this, Facebook, Gmail, Google, all the web applications, right? Web applications, right? So how to develop this for these application softwares? So it depends on the requirements. Suppose if it is a front end some forms, right? So for this purpose, maybe using HTML, right? Yes, HTML front end application. Suppose server side components may be using Java, right? Okay. Suppose storing data for this purpose using database, right? So databases, right? Databases. Suppose sometimes you have to develop some gateways. For gateways using C language or C++, right? C or C++ you can use for gateways, gateway development. Okay, gateways like gateway, just it's a component to transfer data one system to another system. So gateways development you can use C and C++. Network programming, C and C++, right? Gateways. Next, suppose huge amount of data storage, Hadoop. Yes, maybe using Hadoop. That scenario, storing huge amount of data using Hadoop, right? Okay. Suppose sometimes developing open source components. Yes, server side open source components, maybe using Python, right? Okay. Just like this depends on scenario, different kind of scenarios. Suppose sometimes reporting tools. Yes, maybe using BI reporting tools. It's a BI reporting, right? Reporting tools, reporting purpose. Okay, so depends on that BI tools. So BI tools, yes, using for, yes, reporting purpose. BI tools like MSBI, next Oracle BI. Okay, next ClickView, Tableau, all the reporting tools. So depending on that scenario here, we can use different kind of application softwares. You see, except ways all comes under application software. Except ways all are comes under application softwares. Clear? Okay. So this is about application software. Okay, for the purpose of application development. Okay, right? Yes, next. Yes, actually our topic is system software, right? So let us move to system software. System software, this is to interact with hardware components. So examples, device drivers and operating systems, right? Yes, let us see about device driver. So what is device driver? Okay, so what is device driver? So device driver, just it's a program. Okay, so without drivers, devices won't work. For every device, driver required. Okay, to run, yes, to run, yes, to run any device, yes, to run any device, driver required. To run any device, driver required. So without driver, devices won't work. To run any device, driver required. Okay, to run any device, driver required. Without driver, devices won't work. Okay, right? Just like devices like a printer, yes, printer. Okay, suppose scanner, scanning machine. Scanner means image scanner. Scanner, okay, image scanner here, scanning machine. Okay, suppose fax machine. Okay, some fax machine. Yes, maybe TV. Right, okay. Yes, your computer connecting to all these devices, right? For this some drivers required. Yes, in these drivers also there are internal drivers and external drivers. Internal drivers are part of OS. Internal drivers are part of OS, means inbuilt with OS. For example, keyboard, these are the part of system, right? Keyboard, mouse, hard disk, RAM, motherboard, processor, all the hardware components, right? Every hardware components will have driver. So these are part of your computer. So internal devices, right? Internal devices. So its drivers are also part of OS. Internal drivers. Internal drivers are part of OS, right? Next, external drivers used for external devices. Printer, scanner, fax machine, TV. These are external devices, right? Externally connected to your laptop, right? Maybe your system, right? So for that case, separate drivers required. External drivers required, right? So the drivers, we should get the drivers and place into your system, then you can use the device. Just you can use the device, right? Okay, all the drivers just install into your system, then you can use devices, right? Suppose any new device released in the market here, the device manufacturer will give the driver here, the driver placed into your system, and you can use that. The driver just you put into your system and you can use that device, right? Okay, so exactly what is this driver here? Just it's a program. Device driver just is a program here, nothing here. In software, everything is program, right? In software, everything is program. Just it's a program. Okay. See, almost all drivers were developed in C language. Drivers, it's embedded C, comes under embedded C, right? So these are the programs. So device driver just is a program to communicate with hardware components. So what is device driver? Okay. So device driver, yes, it's a program. Device driver is a program. Yes, it's a program. Yes, to communicate, to communicate, to communicate with hardware components. To communicate with hardware components. Right? Okay. So for every device, compulsory drivers required. Okay, right? Yes, if it is internal devices, yes, it's a part of OS. Part of OS internal drivers, right? Suppose external device means you have to install it separately, right? Okay. If that hardware manufacturer will provide the driver just you, yes, place into your system, copy into system, and you can use the device, right? Okay. That is about device driver, right? Yes. Next, OS. This is our part. Okay. Operating system. Let us move to OS. Yes, operating system, right? So what is OS? So what is OS? Here, some questioning here. Yes, can we run any program without OS? Without OS, can we run any program without OS? Say yes or no. Can we run any program without OS? Say yes or no. Yes, what is the answer here? What's the answer for this? Can we run any program without OS? Let me check answers. Can we run any program without OS? No, no. Everyone saying that no. Okay, fine. Well and good. No. Answer is no. Okay. So compulsory OS required. Without OS, there is no computer, right? Yes, in our computer compulsory OS required. Without OS there is no computer. Okay. Yes, let us see that. See here it's like this. Yes, here suppose laptop, suppose your laptop, nothing but a hardware, right? Suppose your laptop purchased. After purchasing laptop, next we should install OS, right? Yes, operating system we should install it. Operating system, right? So first the hardware, on top of this OS you have to install. Okay. After installing OS here, next your softwares. Suppose learning Python, learning Java, learning C. So all these are called as application softwares. Okay, Java, yes, C language, yes, maybe C++, maybe Python, yes, maybe Hadoop, something like this. All these are called as application softwares. Yes, application software like C, maybe C++, yes, maybe Java software, yes, maybe Python, okay, maybe Python, yes, maybe Hadoop, okay, yes, maybe database, database programs, database, even MS Office also. For MS Office also, OS required. So without OS, this will not work. Even for MS Office also, OS required. Okay. So on top of OS, all the programs running, right? Okay. Yes, to run the C program, OS required. C++. To run all the software programs, OS required. Without OS, these programs will not run. Okay. So on top of OS, all the programs running, right? Yes, on top of OS here, all the programs running, right? Okay. So OS giving platform, right? Just it's giving OS giving platform for these all the programs, right? So that means OS is like acting like a platform. So what is OS? What is OS? First point, yes, it is a platform. So OS is a platform. Yes, OS. One second. Let me maximize. Yes, OS it's a platform, right? It's a platform. Simply you can say what is OS? It's a platform. Okay, it is a platform. Yes, where we can run, all the application softwares, where we can run all the application softwares, right? So acting like a platform, right? Okay, so OS is a platform, right? Okay, so what is OS? What is OS? A simple answer here, it's a platform. Simple answer, OS is a platform where we can run all the application software, right? Yes, all the application softwares, right? Okay, so acting like a platform, right? Not only platform here, not only platform, suppose for example here, C program generating some output here, Java program generating some output, or Python program generating some output, right? So all the programs output first of all goes to OS. Okay, these programs output goes to OS here, OS to then output device, right? OS to output device. Suppose these programs reading from the keyboard. Yes, reading from the keyboard. So first the keyboard data goes to OS. Okay, so OS to then these programs, right? This is right. Okay, so between these hardware components and application software, yes, applications of this OS, right? OS. So OS is communicating between these two, right? OS is just communicating between these two layers, right? Hardware layer and application software layer, right? Yes, all the programs communicates with hardware component through the OS, right? So without OS, yes, it can't, right? Okay, so between this application software and hardware, there is a OS. There is a OS, right? So simply we can see it's an interface. Just interface means like a mediator here. So it's an interface, right? So next point. So OS, it is an interface. Yes, it is an interface. It is an interface. It is an interface. Yes, between. It's an interface between hardware. Yes, hardware components. Interface between hardware components and, yes, and hardware components and application software. Just its interface, application software. Yes, application software, right? This is, so this is, it's an interface. It's an interface. OS is an interface between application software and hardware components, right? Okay, yes, next here, OS. OS performing some input output transactions, right? To perform all these transactions here, every OS has its own input output library. There's input output library. So what is library? This topic we'll discuss in Linux ways. Linux ways library, that time we'll discuss here. Library. Actually, library means it's a collection of functions. That library contains all the functions. See, almost all the operating systems were developed in C language. All the operating systems were developed in C language. C functions. That library contains all the C language functions like input output functions. Input output functions, right? Okay. So every ways has its own input output library to communicate between application software and hardware components. To communicate between application software and hardware components. Right? Okay. So this is about ways. Okay. So every ways has, yes, every ways has input output library. Input output library to communicate between application software and hardware components. Every ways, Windows ways, Linux ways, Unix ways, you take any ways here, any ways can is input output library to perform IO operations between application software and hardware components. So this is about ways, right? Okay. Freshers question. For freshers, maybe asking simple question, what is ways? So what is ways? Yes, your answer simply it's a platform. What is ways means it's a platform where we can run all the application softwares. Right, okay. Next, it is an interface between hardware components and application software. Next, every ways has its library to communicate between application software and hardware components. Just these points, just mention these points enough, right? Yes. Let us see the document here, class document. Yes, all the topics I have prepared document here. So don't worry about notes here. Running notes is not necessary. Don't try to write running notes. It's not necessary. Wasting of time for you here. So try to focus on the class. Okay, try to understand the class topic here. Okay, yes. No, yes, for big font size, increase that simply. Okay, right, okay, fine. So this is extension document. Okay, 200 size. Okay, fine. Thank you. Yes, so this is class document here. Yes, I'm minimizing this is. See, every topic it's there in class documents. Okay, no need of writing any running notes. So whatever topics I'm explaining in the notepad topic on this Word document topic, whatever topic I'm explaining here, everything in the order prepared here. It's prepared very clearly. Try to understand the class. Okay, don't deviate your time in writing notes. Okay, yes, if you're writing notes may not be understanding class here. Okay, try to understand class very clearly. Of course, you can watch the video once again. Yes, yesterday video, try to watch it today once again. Okay, yes, you'll feel very happy. Yes, even myself also. Yes, yesterday night I watched that. Yes, that unbelievable explanation. Even myself also not believed. Yes, I explained in such a way. Yes, everyone can understand very clearly explained doc. Yes, yesterday class. You watch that, not on this one, not on Linux, you can watch that a Hadoop video or Python video, Java video or C, whatever I'm topic explaining, just try to watch it here very clearly, each and every topic explain without any confusion here, without any lagging in the words expression here, without any gap, continuity is there. So try to watch yesterday video, you'll see this. Okay. Yes, even myself also surprised. Yes, after watching yesterday video. Okay. Yes, many videos I have uploaded to YouTube here, but not watched. Yesterday, interestedly, just I got the time yesterday night here. I watched it. Yes, yesterday after uploading, just within half an hour, almost 125 members watched that video. Just half an hour within after uploading within half an hour, 125 views we got it. Okay, yes, I think today somebody maybe watched here, maybe many views will be there. Yes, let me check. Okay, yes, I'll check it later. Okay, yes, now So let us see this same thing, same topic. What are we discussed here? The basics, software basics of software here. Software, it's a collection of programs like C, C++, Java, SQL, and other programs, right? Software basically two categories: system software, next application software. Okay, application software for the purpose of application development, right? Okay, like C, C++, Java, .NET, ERP packages, all the application softwares. System software, yes, it interacts with hardware components. Okay, example, device drivers and operating systems. Okay, so what is device driver? So what are we discussed? All the points mentioned here. Here all the points mentioned. Next, what is OS? Same all the points. Okay, it's like it's a platform where we can run all application softwares. Next is an interface. Next, every OS has its own libraries to communicate between application software and hardware components. See that OS architecture, hardware. Okay. Next, operating system and application software. So till now, whatever discussed here, till now, whatever discussed. Yes, sir. Yes, Durga Google Drive. Yes, go to Durga Google Drive. Sorry, not Google Drive. Durga YouTube. Just go to YouTube. In YouTube, search for Durga Linux. Durga Linux. It shows class 1. Durga Linux. Okay, just in YouTube, search for Durga Linux. Durga Linux here you can see class 1. Yes, all my videos. Yes, YouTube videos. Yes, in YouTube, just you can search my name here. You can get all this. Okay. Yes, like Linux videos, Hadoop videos. You can see that. Right? Okay. Yes. So this is till now whatever discussed. Everything is a document, correct? Yes. Next topic. See, DurgaSoft, Hadoop by Nageswar Rao. Yes, sir. DurgaSoft, Linux by Nageswar Rao. Yes, Linux demo. When this is 7 months ago, this is old one. Next 7 months ago, yes, 12 p.m. This is yesterday's. Yes, 13/4. This is. Yes, yesterday I watched up to this. Just you watch it. Okay. Yes, let us continue. Yes. Next. So this is just introduction to ways here. Next, in operating systems, basically two categories. Yes, operating systems basically two categories here. Two categories. Two categories here. Basically two categories. Okay. Yes. Someone sent that YouTube. Okay. Yes, basically two categories. First one, character user interface. Second one, graphical user interface. Character interface and graph user interface. Right, okay. CI or CLI also. Anyone you can take it. Character interface or graphical user interface. Okay. Yes, here first one character interface, next one GA here, graphical user interface here. So this is character, yes, character user interface, character interface or command line. CLI means command line. Yes, command line interface, command line interface, command line interface, character user interface or command line interface. GA means is a graphical. Yes, graphical. Yes, graphical user interface. Graphical user interface. Okay, graphical user interface, right? This is so command line and graphical is like this. So what is CA? What is CL? What is this one here? Let us see about character interface. Yes, this is character interface. Command prompt. It's a character interface. This is character interface. CLS, clearing screen, right? Clearing screen. D drive, that will take to D drive, right? Okay, so D drive like this. D drive, right? So DR, some output getting like this. Okay, see here DR. So what temp is a directory. DR means directory here. This DR means directory. Sample is a directory. Silitech, these are office. Directory is a directory. Python is a directory. Okay, see this. NRIT, this is my personal office here. My personal office. Okay, NRIT, so this is directory here. Okay, so this Silitech is actually working company. It's my payroll company. This is my personal. This personal company I'm using for the online classes and the small projects purpose I'm using here. Okay, yes. So DR, yes, output like this. So DR means directory. Suppose for example test is a directory, right? Test is a directory here. CD test, yes, CD test directory, change, right? DR output here. CLS, clear screen here. So DR, right? So DR means this directory, right? What is directory? Directory folder, both are same. In character interface calling as directory here. In graphical interface calling as folder. Both are same. Only terminal difference. See, D drive test is a directory. In that T1, T2, yes, X1, X2, they are all directories, right? All are directories. Yes, let us go to GA. See, this is GA, right? Yes, D drive test folder. See the test folder, right? Test folder in this D1, D2, D3 directories, right? Directories. See here D1, D2, D3 are directories, right? Directories. D1, D2, D3 directories, right? Same thing here is a folder. So folder directory both are same, no difference. Okay, both are same here, no difference here. Yes, in character interface calling as directory. Yes, is a directory, right? Same thing in graphical interface, a folder here. Both are same. Folder contains subfolders and files. Folder contains subfolders and files. Directory contains subdirectories and files. Yes, about directory, more about directory we'll discuss in Linux base. In Linux base, yes, every topic dealing with directories. Directories concept in Linux base. That time we'll discuss. Okay, right? CLS, clearing screen, DR output here. Suppose for example X, CDX, changing the X location, right? Yes, CLS, clear the screen, DR some output like this. That X inside of X again X1, X2, right? X, yes, X directory, X folder, right? Open that, you can see X1, X2 folders, right? Same thing here directory. X1, X2 directory, right? This is okay. See, what is this DR? This DR stands for what? See, this DR stands for directory. This is stands for directory. This means directory. What is this DR? That command DR. What is that command DR? Anyone idea? What is this DR? DR means what? Anyone idea? Yes, of course, I am here to explain. Yes, just I am asking your idea. No idea? Yes, same like Linux. It shows all folders, okay? The DR stands for what? This DR stands for directory. This DR stands for directory. What is this DR? This DR stands, the name stands for what? That name. See, this DR means directory, but this name is not a directory here. This dir means not a directory. So what is the dir here? What is the dir? Yes, the dir, yes, small lowercase dir. So the dir means, yes, disk information reports. Disk information reports. The directory, the dir stands for disk information reports. Yes, it shows the contents of disk, right? Disk information. The dir stands for disk information report. Disk information report. Disk information report that shows the contents of disk. Okay. Yes, just you check in Google the dir. Okay, DOS command dir stands for what? Disk information report. Okay, that is dir here. See, this dir means directory, but this dir is what? Disk information reports. So this is character interface. Yes, in character interface we must have commands knowledge. Suppose creating directories, md suppose x3 created, right? Okay, md suppose t1 created, md d1 directory created, right? Creation of directories like cd x1 change, right? Okay, yes, dir output. Okay, present working location, cls present working location of the path. We are at this location, this is a path, right? We are at this location. Okay, yes, all the commands you must have this commands knowledge here. Just to work with the character interface you must have their commands knowledge, otherwise you can't. Okay, see, this is very simple. It's a DOS OS, MS DOS, Microsoft Disk Application. It's very easy. Yes, if you know the Linux, this is nothing here. These commands almost similar to Linux base. Linux thousands of commands are there, but in DOS limited. Just maybe matter of below 100 commands. Yes, in DOS with just below 100 commands are there. Help. Yeah, this gives the all DOS commands. They are DOS commands. Just below 100, maximum 50, 30 to 40 commands are there. All the DOS commands. Okay, all the DOS commands. Okay, DOS command just a matter of 30 to 40 commands. That's it here. But Linux, many commands, thousands of commands are there. Yes, we'll discuss Linux base. Okay, so once you work with Linux base, this DOS is nothing here. It's very simple. So this next exit closing session, that is this is called DOS shell. This is shell, DOS shell. This is DOS shell. So this is character interface. Next, this is graphical interface, right? So this is character interface and graphical interface. Yes, operating systems, character interface and graphical interface, right? Yes, character interface, command and user interface, GUI. So this is users working with folders and files icons, right? Yeah, this is user friendly. GUI, it's user friendly. Character interface not user friendly, right? Next, in both cases, this is single user and multi-user operations. Single user and multi-user. Single user and multi-user. Okay, both cases. Yes, character interface graphical. In both cases, yes, there is a single user OS. Next, multi-user OS. Single user OS and multi-user OS. Single user and multi-user, right? So, what is single user? What is multi-user OS? Let us see one by one. First, about single user OS. Yes, nowadays we are not using single user OS. These applications were outdated. Yes, what is that? We'll discuss. What is single user OS? Single means only one, right? Only one user. Only one user can use. Only one user can use system. Only one user can use system resources. System resources, right? Yes, system resources like file, maybe file. Yes, maybe data using here. Yes, maybe some application running on some system, some app, right? Only one user can use this. Only one user can use this. Okay, only one user can use the system resources. That resource could be file or data or some application, maybe file, maybe data or some application. Only one user can use this. Okay, yes, here it does not support. If this one, it does not support networking. There is no networking facility. No networking. It does not support networking. Okay, yeah, this is called as standalone operating system. This is standalone OS. This is standalone operating system. This is standalone operating system, right? It does not support networking. Yes, here there is no networking, right? If no networking, how can you share your files? Suppose in your system some file is there, right? In your system some file is there. That file you want to transfer to a team member. Yes, maybe development team, right? Maybe Java development team or maybe Python development some team, right? Suppose if you want to transfer some file here, how can you transfer? Some networking required, right? To transfer that networking required. But here the standalone system is standalone ways. This standard OS does not support networking. Since don't have networking, we can't transfer the files. We can't share the data. So only you have to use that files, right? Yes, you can't give to other sites. No transferring. Yes, no facility to transfer it. No networking. So only you have to use it, right? Others cannot share your data, right? So this is called a standard OS. Okay. So what are the examples of this topic we'll discuss next? Examples we'll discuss next here. Okay. Next, multi-user OS. So what is multi-user OS? Multi-user means more than one. Okay. So multi-user means more than one user. So multi-user means more than one here. Okay. Yes, multi-user. Yes, more than one user can use system resource. Yes, more than one user can share. Yes, sharing here. It's a sharing. Okay. More than one user. More than one user can share the system resources. Okay, like files. Okay, files, maybe data, maybe applications. Okay, more than one user can share it. Okay. Next, it supports networking. It supports networking. Networking facilities available. Since networking facilities available here, we can transfer the files, right? We can transfer files. We can share the data. Okay, right? Yes, this is called as. Yes, it is called as. Yes, this is called as server OS. This is called as server. So this is server OS. It's a server. This is called as server operating system. Yes, what is server? Yes, let us see. So what is server? Server means serving something, right? Yes, server and client. Who is serving something, that is called a server. Who is taking something, that is client, right? So for example, Facebook application is server, right? We are the clients for the Facebook. We are uploading and we are downloading from the Facebook, right? Okay, so we are the clients. Facebook is a server, right? So server, which is providing data, which is serving, that is called a server. Who is taking? It's a client. Okay, now let us see how server OS is working. Let us see about how server OS is working here. Yes, 1 second. Document in this server. Yes, some text box. This is server. Suppose this is server operating system. Server OS. Yes, that could be Linux or Windows, something like this. Server OS, right? Server OS. Okay. Server OS. Yes, on top of server OS, something is available. Okay, on top of server OS, suppose. Yes, on top of server OS. 1 second. On top of server OS, yes, maybe file is available. Maybe files. Okay. Yes, maybe some database. Yes, on top of server OS. Yes, maybe files available. Okay. Yes, maybe data available. Yes, maybe some application app. Yes, app, something like Facebook application, something like this. Yes, maybe Facebook application. For a better understanding, I'm mentioning Facebook application. So server OS, right? The server OS, maybe Linux server or Windows server, something like this. This server OS supports networking. Okay. Yes, here it's supporting network net. Because of networking here, from different locations of the world, from the different locations of the world, yes, we can connect users. Okay, user or client here. Suppose user one. Okay, yes, users. First user, right? First user, next user, yes, next user, next user. Okay, next user, next user, next user, next user. Like this, multiple users connecting from across the world, right? Yes, users, different users here. Okay, yes, user one, yes, maybe user two, yes, user three, next user four, yes, user five, yes, user six, multiple users, more than one. Okay, user seven, yes, user eight, yes, maybe nine, maybe n number of users like this. Multiple users, right? Okay, more than one, more than one. Okay, so more than one, yes, that could be here, more than one. Yes, see, that could be, yes, that could be two or 3 or tens of users or hundreds of users or thousands of users can share the system resources. Thousands of users. Okay, so thousands of users can share the system resources. Okay, so that is called a server wise. Okay, see here users. Yes, users. Yes, user one connecting to OS here. First request go to OS here. First, with the help of networking, that OS supports networking. Since support networking here, that user first of all connecting to OS. After connecting to OS here, then accessing files here. Accessing files. Maybe accessing some data. Yes, maybe taking some Facebook application, accessing Facebook application, right? See, so in Facebook here, for example, Facebook. See Facebook, that URL, right? www.facebook.com, right? Facebook.com. So let us see some example Facebook application. Some example Facebook application www.facebook.com, right? So here when you submitted this request, now this request converts into some IP address. IP address, yes, something like 192. 1 second. Ping www.facebook.com. See, it's pinging here, right? Ping. See, this is Facebook IP address, right? www.facebook.com. This is converted to this IP address, right? 157.240. So this is Facebook IP address. Yes, 157.240. 157.240.217.35. Yes, 217.35, right? This is. So what is this one? It's a IP address for the Facebook server. Okay, www.facebook.com. This is called as DNS name, domain naming service. Yes, about domain naming service we'll discuss in Linux ways. How to configure DNS names, the domain naming service. Okay, so this is DNS, domain naming service. DNS, right? It's a DNS name. How to configure DNS names? This DNS name concept we'll discuss in Linux ways. So this DNS name converts into this IP address. DNS name, it's a logical address here that converts into physical address like this. So the physical address, it's a address given to, yes, that Facebook server here. Suppose server was, right? So this is physical address, right? Physical address. For this map name is this, right? So this name mapped to this address, right? How to map it? That mapping names we'll discuss next. Okay, Linux I'll explain this. Okay. Yes, one more here. So ping. So durgajobs.com. Yes, that server is working. Yeah, durgajobs.com, right? That is 198.198.57.131.24, right? So this IP address, right? This is okay, right? Yes, here like this. So mapped address, right? So that converts into address here. Yes, using that address communicates with this, right? Yes, for your system of this IP address. See, IP address, my system, IP config. This is IP address of my system in network. Yes, in network. IP address 198.160.0.2, right? This IP address, every system has some IP address to communicate network here, right? To communicate in the network. This is called IP address. IP, Internet Protocol address. IP address, right? Yes. So here, that URL simply here. So that www.facebook.com. This URL converts into physical address and communicate with that, right? Using IP address. Yes, in networking, always communication happening using IP address. So user one using IP address, connect to this OS here. So this OS is configured with this IP address. This OS is configured with this IP address, right? Okay. Yes, here this is Facebook IP address, right? So Facebook is running on Linux base. Facebook is running a Linux base here. That Linux base IP address this is. Okay, right? So like this, durgajobs.com. That site is also running on Linux base. That is server IP address. That Linux server base. On top of that, durgajobs.com is running, right? Okay. So this is IP address, right? So that is converted into IP address and connect to the server. After connecting here, now files. Yes, accessing files, maybe accessing Facebook application, something like this. Okay, right? Yes, like this. Yes, from different locations of the world here. Yes, next user. Okay, so next user. next user like this, all that users. So with the help of networking connecting to the server, right, all that users connecting like this, user 1 2 3 4 5 6 7, yes, all these users just connecting to server using networking, right. Yes, server wise it supports networking. Since supporting networking here, yes, through the networking here they can connect to the server, right. After connecting the server here, then go to files and taking files data and like this, right. So this is this type of OS is called server OS, supports networking. Multiple users, yeah, from across the world, different users are using Facebook, right. Yes, we are sharing Facebook application from different locations, right. How that is running on server OS. Okay, so anything is available on the server OS is a shareable, right. Suppose for example like a development company, there is a development team, Java team, right. That Java team wanted to use common data. That common data they will keep on one system, common data keeping in one system, right. That is server system, right. So okay, from different developers connect to that system, they can take the data, right. That is server OS. The data must be on the server OS. Okay, right. Suppose any application developed, yes, any application developed, yes, if you want to publish, okay, if you want to publish to the, yes, publish in the market, right, from any different location action, right, that application should be deployed in the server OS. Once deployed in the server OS here, from anywhere you can access. Once deployed in the server OS, that you can access from anywhere, right. So application deployed in the server OS here, this server has to put into network, internet, right. This server has to place in network. Yes, see, how to place this server in network we'll discuss in administration. Linux administration is a topic here. So how to configure IP address, how to configure DNS names, next how to put the server into network. So after putting network, we have to unblock some port numbers for communication purpose. All the topic we'll discuss in administration. It's a Linux admin topic. That time more about we'll discuss. Practically you can see that. Okay, right? Yes. So this is server OS, right? Okay. So multi-user OS, right? Called as server OS. Okay. So this is difference between single user and multi-user OS. Okay, fine. Now let us go to document here. So this is our document in this. So you get character interface, single user and multi-user. Graph interface, single user and multi-user, right? Now let us see examples. One by one examples here. Character interface, single user ways. What is example? Yes, it's a MS-DOS. MS-DOS, right? Now let us see one by one here. History of all the operations. Okay. Yes, history of, one second. Yes, history of all the operations one by one you can see here. One second. Okay. Yes, let us see one by one here. First, character interface, CA, right? For this example. Okay, first let us start with DOS, MS-DOS. Microsoft Disk Operating System. Microsoft Disk Operating System. Okay, first let us start with DOS here. Because a first OS in the market here, MS-DOS. Yes, it is a, yes, complete history we'll discuss. Yes, it is a first OS in the market here. First OS in the software. First OS in the software field, right? Yes. Yes, it is first OS in the software field. Okay. Yes, it was released. Yes, it was released. It was released in the year 1947. So 1945. 1945. Okay. MS-DOS. It's a first OS. It was released in the year 1945. So first OS in the market is MS-DOS. Microsoft Disk Operating System. This is first one, right? Next is a character interface. Yeah, this is character user interface. This is character interface. Next is a single user OS. This is single user OS. Single user operating system here. Okay, single user OS. So this is called a standalone. This is standalone. Standalone. Stand alone. So standalone, right? Stand alone means only one, right? Standalone. Okay. standalone operating system, right? This is so. This is about MS-DOS, right? This is first way in the market here. After MS-DOS, next Unix. Yes, Unix also character interface. Yes, Unix. Okay, Unix. This also character interface. Yes, it is character user interface. Okay. Yes, Unix. Yes, it was. Unix was developed. Unix was developed in the year 1973. Yes, Unix was developed in the year 1973. 1973, right? Yes, 1973. How many years? Almost 50 years, right? 50 years back, Unix was developed. 47 years. Okay. Yes, still it's a character interface, no change. With Unix base, no change. Yes, still it's a yes since 50 years, almost 50 years each, right? Okay. Still it's a character interface. Okay, no change. Still it's a character interface. Okay, right? Yes. So this Unix, see this Unix. So this Unix, it was developed in C language. Unix was developed in C language. Developed in C language. See, almost all the applications were developed in C language. So Unix also developed in C language. Right? Okay. Yes, it was developed in C language. Next, yes, it is a first server. Yes, it is a first server in the market here. First server. It's a first server OS. First server OS. Yes, DOS is not a server. Okay. So Unix is a first server. It was developed in C language. So Unix was developed in C language. Yes. Who is the author of C language? Any idea? Who is the author of C language? Yes, guys. Anyone? Can you answer this? Who is the author of C language? Can you ping in box, at least chat box? Yes, guys. Do you hear me? Hello. Okay. Dennis Ritchie. Fine. Fine. Well and good. Dennis Ritchie. Yes, Dennis Ritchie has developed. Okay. Yes, Dennis Ritchie. Okay. Yes, in C language. Yes, it was developed in C language. C language by some team. Yes, Dennis Ritchie, the team members. Dennis Ritchie. Okay, next. Brian. Yes, Dennis Ritchie, Brian Kernighan. Brian Kernighan. Brian Kernighan. Next, Ken Thompson. Ken Thompson. Ken Thompson. Yet Ken Thompson. Yet AT&T Bell Labs. AT&T Bell Labs. Ken Thompson at AT&T Bell Labs. AT&T Bell Labs, right? This is okay. Yes, it was developed in C language by the Dennis Ritchie. Next, Brian Kernighan, Ken Thompson at AT&T Bell Labs. They are the employees of AT&T Bell Labs here. Yes, it's a company in USA. Okay, USA. Okay, Silicon Valley. It's there in Silicon Valley. AT&T Bell Labs. Right? Okay. Yes, Unix was developed by yes Dennis Ritchie. It was developed in C language. It was developed in C language. Yes, released in the year, not released to market here 1973. Just developed at AT&T Bell Labs, but not released in the market here. Next, in the 1980s, in 80s released the market here. 90s got the popularity. What's the reason? Getting popularity for Unix base. We'll see next. After entering the actual topic, we'll discuss why popular like Unix has Unix and Linux. Why has this much of popularity? We'll discuss next here. Okay. Next here, from the beginning, yes, Unix. From the beginning, Unix is an open source operating system. From the beginning, Unix is an open source operating system. Yes, it's a open source. Open source operating system. From the beginning, it's a open source operating system, right? So open source. So what is open source? Yes, what is difference between Unix and Linux? Yes, we'll discuss. Wait. After finishing all the basics, we'll go to that Unix and Linux here. That time we'll discuss. Okay. Yes. From the beginning, Unix is an open source operating system. So let me finish all the basics, various basics. After that, we'll go to that discussion. Okay. See, in actual topic. So these are topic now we are discussing here. This is actual topic. Unix, Linux. Next. Yes, that time we'll discuss what's the difference between Unix and Linux base. Okay. Yes. Yes, from the beginning, Unix is an open source operating system. Open source. Okay. So from the beginning, Unix, it's an open source operating system, right? Yes. What is open source? Yes. Here. No. Here. What is open source? Yes. Anyone? What is open source? Any idea? See, there are two things here: freeware, freeware, and open source. Freeware and open source. Freeware, open, the both are not same here. Yes. Free open source. Flaws. Someone saying that FOSS. So this, I think this guy learning Python. Arvind. Okay. FOSS means, okay, FOSS. Free open source software. That's okay. Yes. Okay. Unix is a FOSS. Yes, actually it's a flaws. Okay. Free and library. Free and library. Open source software. Okay, flaws actually here. That concept is called as not flaws here. It's a flaws. Free or libra. Open source software. That's a flaws. Called as flaws actually here. Not flaws here. Flaws actually. Okay. So what is exactly open source and freeware? Freeware, open source, both are not same. There's a lot of difference here. What's the difference here? Freeware means that software can be downloaded, can be downloaded yet free of cost. Downloaded and used. Downloaded and used yet free of cost. Just yet free of cost, right? Free of cost. So no licensing, nothing here. Yet free of cost you can use. Downloading and you can use at free of cost. Next, what is open source? Yes, see, if it is open source here, that can be downloaded, including source codes, including source codes, Yes, including source code, right? Including source codes and can be modified. Yes, and can be modified. Okay. Yes, including source code that can be downloaded, including source code and can be modified. Not only modification here, and also can be redistributed. And also can be, yes, and can also be redistributed. Redistribute in the market. You can redistribute here, distribute in the market, right? Can also be redistributed in the market. Okay, right? Yes, see, freeware, just this can be downloaded free of cost and you can use, but we can't modify. Freeware cannot be modified here. If it is freeware, simply just freeware, free of cost using, but we cannot modify. For example, here there are some tools in the market like Putty. It's a freeware. Yes, free of cost. Downloading, just using here. Okay, Putty, right? The Putty. Yeah, this Putty we can use, right? Yes, Putty is having some features like session, terminal, window, connection, something like this. There are some features, right? These features you cannot modify here. Some port number, yes, using raw socket or telnet or R login, SH, yes, serial, right, like this, right? There are some features. Okay, these features you can use as this, but you can't modify. This is kind of freeware. This is kind of freeware. Putty. Next, WinSCP. Okay, yes, in Linux we are going to discuss all this. What is Putty? How to work with Putty? How to work with WinSCP? So these are freewares. Its features cannot be modified. Okay. Next, what is open source? Open source means it can be downloaded, including source code. For example, Unix is open source, right? Unix is an open source. Okay. That Unix we can download, including source codes, including source code. You can download it and we can modify. After modification, then you can redistribute the markets. Yes, you can sell in the market with your name. For example, durgasoft, they can download, compute that Unix source code, they can modify and redistribute in the market with name durgasoft, right? Yes, Durga Unix, like a Durga Unix, right? Okay, yes, that is open source. So open source freeware is different here. Freeware, free of cost using, but it cannot be modified. It cannot be modified. Open source means yes, it can be modified. Its features can be modified. If you're able to modify that, yes, its source code. If you're able to modify its source code, that is called as open source. Okay. Yes, Unix is open source. Even latest Linux also open source. Hadoop is open source. Python is open source. Like there are some open source softwares, including open source code. You can download it and you can modify features, right? That is called as open source. Yes, Unix is a open source, right? Yes, since Unix is a open source here, many companies taken the source code and modified, released with different names like Linux. Linux is a modified versions of Unix base. Linux base, next is Solaris base, Linux base, next is Solaris base here, next IBM AX, IBM AIX, IBM AX here, next HPEX, right, from the HP company. Okay, so different companies taken the Unix source code, modified, then release different names here like Linux base, next Solaris, IBM AX, and HPEX. See, these are the modified versions of Unix base. So these all are modified versions. Okay. So modified versions of Unix base. So these are called flavors. They are flavors. They are flavors of Unix base. So all these are flavors of Unix base, right? So flavor means just one kind. Flavor means one kind, right? Simple. Flavor means something like see, there is ice cream, right? In ice cream, different flavors available. Yes, in ice cream, different flavors. That flavor changing. Ice cream is ice cream, right? But flavor changing here. Same like that here. Yes, Linux and Solaris and IBMX, HPX. These are the flavors of Unix base. Next, Linux flavors are different. Linux flavors are different. What are Linux flavors? We'll discuss next year. Okay. Yes, right. Someone saying that originally VS Code is Unix here, that vendors making different flavors like Linux and all this. Okay, so Linux is a modified versions of Unix base. They are all the flavors of Unix base. Flavors or distributions also. Distributions. These are the different distributions of Unix base. Okay, so flavors or distributions. Right, okay. So here, because of Unix, it's a from the beginning it's open source. Many companies taken the source code, modified, released with different names, right? Okay. Yes, one more BSD, Berkeley Software Division, BSD Unix. That is one more flavor, but not released in the market. BSD, Berkeley Software Division. Yes, they have modified Unix base. They use it for their own purpose. BSD, Berkeley Software Division. Yes, distribution. Okay, Berkeley Software Distribution, not division, distribution. Berkeley Software Distribution. That is one of the distributions of Unix base. Okay, BSD also one of the distributions of Unix base. Okay, 1 second. Not only BSD here. My first project, my first project, my first project. Yes, in 1997 with Motorola, same project. Motorola, same project. With Motorola here, yes, 1997, yes, engineering, final year, yes, campus selection. I got the job with Motorola. Okay, so joined with Motorola. With Motorola, my first project is embedded C project. Yes, Unix based modification. Motorola, it's a famous, yes, in 90s, very famous for the electronic goods. Motorola company, Japanese based company, very famous for the all the electronic goods. To operate Motorola devices, we have developed separate platform. So for that, we have taken complete Unix source code, modified, and developed separate ways to operate their devices. We have developed that OS here, but not released in the market here. Just use it for their own purpose, because many features to operate their devices, right? Just I'm a team member of that OS here. Motorola operating system, their own platform. Okay, yes, they have built their own platform here. Okay, to operate their devices. Right, okay. Yes, in that project, my role, yes, my role was shell development here. Shell development. Yes, I have developed shell here. Shell development. My role, shell development. Okay. Next, other features. Yes, other team members. Yes, the team is very big team. Yes, almost more than 50 members team is there. Okay. Yes, that complete that weighs more than 1.5 year we have developed here. So 1 year development, just 6 months for testing. After testing, we have started using here. Okay. Yes, my role was shell development. Yes, the shell developed in C language. Okay. Yes, already in Unix there is a shell. Okay. We have taken the source code completely shell. We have modified and developed a separate shell. Developed separate shell, yet to support Motorola, yes, to support all the Motorola to operate Motorola device, right? Yes, how that shell was developed, I'll explain you. The behind of shell, some C program, I'll explain that shell. Get the skeleton, the program skeleton I'll explain. Yes, Linux architecture is there that time I'll explain shell, correct? My role was shell development, correct? So Motorola, even Motorola also developed their own products. Like that, many companies, Motorola, next Berkeley Software Division, like this, many companies taken that operating system, modified, and they have used their own purpose. But some of that products are released in the market here, like Linux, Solaris, IBMX, and SPX. Okay, Solaris from the Sunsoft, IBMX from the IBM company, HPNX from the HP company, right? Like these different companies taken that Unix source code, modified, and released with different names, right? So these are all the distributions of Unix base. Okay, fine. So about Unix base, yes. See this character interface. See character interface, single user, MS-DOS example. Yes, character interface, multi-user OS examples, Unix, Linux, Solaris, and IBMX and SPX, right? Character interface, multi-user OS. Now let us move to GUI, graphical user interface. GUI, yes, let us see that. GUI here. GUI. Yes, GUI, graphical user interface is user friend, right? Yes, GUI Windows. Yes, GUI Windows is the first OS. Windows is a first GUI. First GUI, right? Yes, released. This was released. So released. Yes, released in the year 1990. Okay, Windows is a first GUI OS. Windows is a first GUI OS released in the year 1990. Right? Okay. Yes, Windows. It was developed in C language. This also. Of course, later changed to C++. Okay. So developed in C language here. Later changed to C++. Next again changed to VC++. Okay. So behind of that Windows OS VC++ common decom component working here. First initially it was developed in C language. Okay. Later C++ here. Later VC++. Visual C++. Yes. In 90s VC++ very famous. Before Java coming to market here, VC++ very famous. Okay. Visual C++. Okay. Yes, Windows, it was developed in C language here. So later, yes, C++. Next after that, next finally VC++. Finally VC++. Right? Okay. Right. Yes, it's a first GA base. First version of Windows OS. Win 1.0. First version in the year 1990. Right. Okay. Next version of Windows OS 1.1. This is in the year 1991. 1991. Second version, right? Yes, first version 1990, second version 1991 here. Next third version, yes, Win 1.2, 1992. Next version, yes, Win 1.3, 1993. Next version 94, yearly separate version, adding some features and releasing with different names. Okay, next 95. Yes, in the year 95, that version named as 95, Windows 95 with year name, right? Yes, with Windows 95. Yes, Microsoft, yes, got lot of popularity because of its features. Yes, Microsoft, yes, 95, because of Windows 95, Microsoft got popularity in the market. For Microsoft popularity started with that OS here. Popularity. So because of this popularity, yes. So because of this Windows 95, yes, Windows 90, because of this one, Microsoft got that popularity. Yes, it's a fully fledged GUI, easy to operate this, user friendly. Right, okay. Yes, next. After that, Windows 98. Yes, this is with some more features added, released as, yes, Windows 98 in the year 1998. Right, okay. See, up to Windows 1.4 called as Win1.x version. These are Win.x version here. So they are called as Win1.x version here. Right, okay. Yes, all this Win1.x version on 95, 98. Yes, all these are, yes, yes, all these are standalone systems. Standalone. All these are standalone systems here. These does not support networking. Standalone systems. No networking concepts. All these are standalone, yes, operating systems. Operating systems. Standalone operating systems. Okay. Does not support network rates. This does not support networking. Right? Okay. Next, during the period, yes, during the period 1994, okay, 94 and 1995, yes, internet evolvement started here. Internet evolving, yes, internet was evolving at the time. Yes, internet was, yes, evolving. Right, okay. Yes, to support, networking, maybe local area networking or internet here, to support networking here. Yes, Microsoft, yes, added. Microsoft simply added networking technology with Windows OS. So networking technology to Windows OS and released as Windows NT. Okay, Windows OS, then then released as Windows NT. So Windows NT means networking technology. NT means networking technology, right? Yes, Windows NT, yes, it supports networking. Okay, so Windows NT supports networking. It's a first server. Yes, it is a first GA server. It is a first GA server in the market from the Microsoft. First GA server, right? Windows NT. Windows NT. This is near. Yes, this is yes, in the year 1998. Yes, Windows NT in the year 1998. After Windows NT here, next added some more features. Windows 2000 server next. After Windows 2000, next is Windows 2003. Yes, after this, next Windows XP. XP in the year 2004. Yes, XP got lot of popularity. Yes, Microsoft Windows application first popularity with Windows 95. Windows 95 mostly used this was. Okay, next later Windows XP with these features here. Okay, Windows XP also, like, there's a lot of popularity for Windows XP here. See, between this Windows 3, Windows 2003 and XP, there's Windows Vista released but failed. Windows Vista failed. Windows Vista but failed here. So this is failed ways. Okay, Windows 2000 next XP here. XP is the most popularity that time. Okay, see, till 2005, sorry, to 2015, till 2015, many companies used Windows XP. Yes, even Windows 10 is there in the market. Windows 7 is there, 8 is there, 10 is there, even 10 is there. Yes, many companies they have used this Windows XP 2015. Later they have changed to 7. So next is Windows 7. Yes, 7 also most successful ways. But 8 not most successful here. Next most successful is Windows 10 here. Now Windows 10, Yes, most successful ways. One of this is. So Windows 10 is a recent, right? Windows 10. Now latest way is Windows 10 here. So Windows 10. Yes, Windows 10. Yes, recently one feature added. Windows 10 with WSL means that concept Linux shell that supports Linux shell here. Linux shell here. Yes, that feature WSL we can install with Windows 5 here. After installing just like a dash shell, see this here dash command prompt, right? Dash shell like this we can run one shell here. Linux commands you can practice. Linux command Windows 10 with WSL concept here. That Linux shell this is. Yes, in this shell you can practice commands. Just commands practice here. Okay, without installing Linux basically you can practice commands. Yes, Windows base, but you can't feel that real time. You can't feel that. Okay, so better install Linux base on your Windows base. Okay, shell is available here. Yes, here this is just only practicing Linux commands. Okay, but you can't feel live, right? Okay, next latest Windows, yes, Windows 12. So next version is Windows 12 here. Windows 12 Lite. Windows 12. Windows 12 Lite. So what is Lite here? So this is with Linux kernel. Yes, Microsoft. Microsoft they have taken Linux kernel added to Windows 12 and releasing as Windows 12 Lite is officially not yet released here, just only internally released here. Why this Linux kernel here? So what's the reason for the Linux kernel? Security purpose. For the purpose of security purpose here, they have purchased Linux kernel here and added to Windows 12. So Windows 12 is a light one here, light edition, like Windows 12 Lite edition. This is with Linux kernel, right? Yeah, this is latest Windows OS, right? Okay. Yes, here now we can use Windows 10 here. We can use Windows 10 to work here. Windows 7 already support withdrawn. Windows 7 support is not available. Okay, Windows 7, Windows 7 support withdrawn on 16th 16th Jan. Okay, 16th Jan 2020. Recently, just 3 months back. The 3 months back, the support was withdrawn here. So don't use Windows 7. Windows 7 updates not available. Yes, suppose once you connect to the internet here, that OS get updating automatically. Okay. Once you enabled OS update option here, that OS updating automatically. But Windows 7 never updates because the support is not available. That was withdrawn already here. Okay. Just use Windows 10. Preferred Windows 10 here, right? Okay. So these are different operations from the beginning here. 1945 to today. Okay. Yeah, this is my experience. I have seen live. This is okay since 97 started. Okay, 20 years, 22 years of experience in this all that versions. Not on this here in Linux also different versions are there from the beginning. First officially released Linux is 1999. From that I worked on every version of Linux base. All the distributions I have seen all the distributions of Linux base. Next all versions of Windows base, all versions of Unix base, all the things I have seen here. Yes, we'll see one by one. I'll explain. Okay. Yes, Novel Network. Yeah, this is the one of the good company, Novel Network. When it was started your career, Novel Network. Yes, 2000 year. Good. 97. Just I'm 3 years experience than you. Okay. Yes, Motorola. It's very good company. Yes, my career started with good company. Yes, first is always best. Suppose if first company is best company, definitely your career will be good. Okay. Yes. Yes, all that history. This is history about all the operations. Okay. So this is yes, same thing. It's a document here. Yeah, this Word document I will send you. This document I'm saving this one here. Save as yes. G drive Linux match Linux folder. Yes, 7:30 p.m., 9:30 p.m. Yes, let me create another folder for your batch. April month, 12 noon. Yes, voice history. I'm saving this history. I'll share you. Yes, when I'm sharing that software and all this, I'll share this also. Yes, daily documents I will share you. Yes, once I received mails from the online team, I'll share every team. Yes, I will share every, or sorry, once I received emails from the online team here, I'll share every document for every day, daily explanation document on this actual documents. Okay, so this is server explanation here. This also, yes, I'll save it. D drive, Linux, permanent batch. I'm seeing saving here. I'll send it. Okay. Yes, I think don't have doubts for today, right? Yes, any doubts? No doubts, right? So let us wind up our class. Shall we stop our session? Yes, guys. Are you feeling any fast? Any? Yes. Are you feeling any fast or any confusion? Yes, Windows 12 new features definitely. Yes, yeah. Link is same here. Tomorrow also same link. No changing link here. Okay, tomorrow also same. Right? Okay. Okay. Yeah. Thank you, guys. See you tomorrow. Yes, let us find up. Yes, end training for all. I'm ending. Okay. Yes.